Okay, here we go again, guys. Polynomial equations practice part 2. So in the previous video, we solved second and third degree equations, and in this video, I want to solve a fourth degree equation and spend some time on word problems, your favorite, right? Okay, so we have a fourth degree equation here. Note to self, notice it's in that nice standard form, right, where it's set equal to 0, descending order, okay, and like I said here, you might want to hit pause and see if you can find all 4 solutions before watching me do this, but here we go. First, you want to ask yourself, is there a GCF? And clearly the answer is no. Okay, there is no GCF. Then you break immediately into 2 sets of parentheses. Okay, how are you going to split a 25? Not a lot of choice. So 5x squared and 5x squared. Let me give myself some more room there. Minus and plus is minus and minus when you have in factored form. How are you going to split a 36? And you say, well, maybe 6 and 6, or maybe 9 and 4, and you just kind of have to play with that till you get the right combination. I'll hit pause as you think about it, because 36 has a lot of possibilities, right? 6 and 6, 9 and 4, 18 and 2. And this is kind of a funny one, because you start to, let's say you put 9 and 4, right? And you're like, inner makes negative 45, outer makes negative 20, and that definitely does not bring me to negative 61 as the middle term. And then you say, okay, well, what if I put the 4 here and the 9 here? And you really start playing with this, and then you start to see something. Inner makes negative 20, outer makes negative 45. It's still not bringing me to negative 61 as the middle term. And you keep playing, and you sort of exhaust your limits, and then you realize that it's not the 36 that's the problem. That's how you split the 25, but I don't want to give the secret away. So let's say, oh, okay, 18 and 2. Well, outer makes negative 10. Your outer product would be negative 10x squared. Your inner product would be like negative 90x squared, and that's definitely not going to bring you to negative 61 as the middle term. So you start to say, maybe there's a problem with splitting this 36. And you re-scratch and you retry your thought process. You say, or maybe there was a problem from the get-go with splitting the 25. So when you become comfortable with factoring, you'll start to sort of see it in your head. Notice that 36 plus 25 makes 61 as the middle term. So you actually just split the 25x squared, 25 times 1, and 1x squared, okay? And then you split the 36, we'll put 36 here, and 1. And then I always say check your product. So inner product makes negative 36x squared, outer product makes negative 25x squared, and together that makes negative 61x squared, if you add them together, which makes the middle term. So voila, we have it factored correctly. Once it's factored correctly, you say, he's still not, we can break it down further, because that's a difference of squares, and so too is that a difference of squares. This is going to further factor down. This one into 5x plus 6, 5x minus 6. This difference of squares into x plus 1 and x minus 1. And poof, now you're starting to see the 4 solutions. Remember, we had said in a prior video that you can separately set each one of these factors equal to 0, or if you get really good mentally, you can just kind of jump to your final conclusion. So it's kind of like, you can see now, I bet, that negative 6/5, 6/5, negative 1, and 1 is going to be your solution set. Okay? Right there. So I'm pretty confident that by now you're able to look at that and sort of lay a claim on your solution set. So once again, you have fourth degree equation. You're arriving at 4 solutions. We haven't talked about the fundamental theorem of algebra yet, but it does say that there should be at most 4 real solutions to a fourth degree equation. All right. Now let's try another fun one. Say, oh, life wouldn't be complete without a word problem, right? Here we go. Here's a good one for you. Obviously I have the answer pasted there, but the width of a rectangle, and notice, as soon as I see the word rectangle, I'm going to draw it. The width of the rectangle is 6 meters less than twice the length. 6 meters less than twice the length. And actually, going to translate that, right? 6 meters less than twice its length. And what's its length? We don't know, okay? But its area is 108 square meters, and we're told to find the dimensions of the rectangle. Now ignore the fact that this is multiple choice. Let's just set this up in real time. Area is length times width. They're telling us the area is 108. And the length is, we're expressing that as an L. And I'll just use a lowercase l there. And the width we're expressing as 2L minus 6. So now, if you think about it, you have yourself a quadratic equation. I'll write my L cursive so you can tell that's cursive. Okay? So that's a quadratic if you clean it up. 108 equals 2L squared, so distribute the L, minus 6L. If you like, you could use X's instead of L's. I just chose L. But now we're ready to solve it. Okay, so it's a quadratic, so we want to set it to 0, hope that it factors. So I'm going to move 108 to the other side. Sorry, I had some technical difficulties there. I hope you caught the end of that. So let me say that again. So we had designated this as 6 meters less than twice the length, and we had designated from here to here as the length, and we knew the area. I'm just kind of rehashing because my computer was acting up there. We knew the area equaled length times width. We also knew that the area is 108, so 108 equaled length times the expression for width of the rectangle, so 2L minus 6. So I think we had it to the point where we had 108 equals, distribute that, so that's 2L squared minus 6L, okay? Now you have yourself a quadratic, okay? So that's a second degree equation, set it to 0, hope that it factors. Alright, so we'll move what I'm basically going to do is subtract off the 108, move it to the other side. So then I'm going to arrive at 0 equals 2L, and I'm writing a cursive L, 2L squared minus 6L minus 108. Pull the GCF. One of the greatest factoring strategies is to make sure you spot that GCF. L squared minus 3L minus 54. Keep factoring. And you say, what times what makes 54? Say, well, 9 times 6 makes 54. And it just so happens that the difference of 9 and 6 is 3, so that's good news. So L and L, plus and minus. 9 and 6, you'd have to have the 9 here and the 6 here to get back to negative 3 as the middle term. Okay, now here's the catchy part. When you solve that, you get L equals negative 6 and L equals 9. L equals negative 6, or L could equal positive 9. Well, let me write that again. L equals negative 6 or positive 9. Well, it can't be negative. Length can't be negative, so we're going to scratch that. But it could be positive. And now you see the answer key. It says the length is 9. And see, I have the answer checked off here. And the width is 12. So you say, how do you know the width is 12? Well, go back to the original drawing, if it helps you. If the length is 9, and we had translated the width to be 6 meters less than twice the length. Twice the length minus 6. Aha! So 2 times 9 is 18 minus 6 is 12. So that's how we're getting that the width is 12. Alright? So I always say once you decide, so this one is going to lead you to a negative length, this one is going to lead you to length equaling 9, as we see in the solution set. Alright, hope that helps. Sorry for the technical difficulty there. Hopefully this next one will go a little smoother. Ah, another lovely word problem. Now this one's interesting because it's actually not going to factor, but that's okay. We have technology. So this is something you would do in micro and macroeconomics. It's sort of the notion of when does the supply curve, meet the demand curve, and where's that point of equilibrium. So without going too much into demand and supply, let's just look at it from an algebra classroom perspective. So a cool company determines that a supply function for its basic air conditioning unit is given by this polynomial function here. And the demand function is given by this polynomial function here, where P is the price for the air conditioning unit. Determine the price for which the supply equals the demand. Well, if you're a visual person, you know you're looking for the POI, the point of intersection. We will do that on the graphing calculator here in a moment, but let's hold that thought. Okay, so what if we just took like a algebra perspective? So when does 40 plus 0.008 p cubed equal 200 minus 0.16 p squared? Now we had said get everything to 0, make sure it's in descending order. Okay, fine. Then we subtract 200. It's just that sometimes what I'm getting at is we have to lean on technology because it might not factor, and we haven't learned what to do if it doesn't factor. So that's going to lead us to negative, so 40 minus 200, negative 160 plus 0.008 p cubed equals negative 0.16 p squared, right? Then move 0.16 p squared to the other side. And then you run into a little bit of trouble. So, after all that sweat equity, now I'm going to make sure it's in descending form. You're going to have 0.008 p cubed plus 0.16 p squared minus 160 equals 0. Now, the problem is, you can try to pull a GCF out on that. You can even try to get rid of the decimals, but it's not going to factor, okay? Note to self, doesn't factor. So since it doesn't factor, I pulled this on purpose because I wanted to see what can we do. So it doesn't factor, so we're going to rely on technology. We know this is the answer. Let's rely on technology. Here it comes. So what I did was, you can see, I put the supply curve in Y1. I put the demand curve in Y2. I did adjust the window on my calculator here. I hit window. Look at my window there, because I knew I needed to stretch that window to see these two curves. Hit graph. Look at that. Trace. We knew we were going to be looking for a point of intersection. Now there's a cool feature on the calculator. You can hit second calculate, go down to intersect, intersect, enter, and just hit enter like 3 times. It says first curve, second curve, enter. Yep, look at that, 21.86. So the cost for the unit where the supply meets demand, $21.86. So that's why I wanted to mention, like, you can try things by hand, but sometimes you need to resort to the graphing calculator to get to that final answer. Okay? Hope that helps. But if you are out there and you're listening and you're an intermediate algebra student that is not allowed to use a graphing calculator, we can assume that, and you're my student, assume that I'll give you a function that, actually factors once you get it to that moment. That I'll give you something that actually factors. Okay? If you're in an upper level math class, then I'm assuming you'd have access to a graphing calculator. All right. Good luck out there.